Before we knew that time itself can slow or speed, there was a man with a ramp, a ball, and a water clock. His name was Galileo, and he asked a question so simple it was dangerous. What if Aristotle was wrong? This is a model of what Galileo built, a simple ramp, a brass ball. But in the 1600s, this was revolutionary. Because before Galileo, no one measured motion, they just argued about it. This is where Galileo worked. Not a grand laboratory, a workshop. Candles, wood, water, and a question. How fast do things fall? Watch, I roll the ball down thy ramp. The water clock measures the time, drip by drip. When the ball reaches the bottom, I weigh the water. That tells me how long it took. Now watch this, two different weights, large and small. Aristotle said the heavy one would win, but watch carefully. They arrive together, every single time. Weight does not matter. Galileo did not stop with ramps. He pointed his telescope at the night sky, and what he found there would put him on trial for his life. Galileo heard about a new invention from Holland, a tube with lenses that made distant things appear closer. He built his own, and then he pointed at the night sky. Look, Jupiter. And those four tiny dots? Moons. They orbit Jupiter, not Earth. This was the first proof that not everything circled us. Galileo saw this in 1610. Galileo also observed Venus. It went through phases, just like the moon. Full, gibbous, half, crescent, then back again. This was impossible if Venus orbited Earth, but it made perfect sense if Venus orbited the sun. This is Galileo's own drawing. He knew what he was seeing, and he knew the church would not accept it. The church demanded he stop teaching the moving earth. Galileo agreed, privately, but he could not stop believing what he measured. In 1633, they put him on trial. This is where he was forced to renounce his discoveries. On his knees, in front of the church. He was 69 years old. Galileo spent his last years under house arrest. Blind, he could no longer see the stars he had mapped. But he kept working. He dictated his final experiments to his students. Galileo died in 1642, but he left behind something more powerful than any single discovery, a method. Test your ideas, measure everything, let the evidence speak. Galileo died in 1642. That same year, in England, a boy was born. His name was Isaac Newton. He would take Galileo's method and build a clockwork universe. This is Newton's room at Cambridge. He worked alone here. He told no one his discoveries. He was terrified of criticism. Newton darkened his room completely. A single beam of sunlight, a prism, on the wall, a rainbow. Everyone thought the prism added color to white light. Newton suspected otherwise. Watch. I take only the red light, I pass it through a second prism. If the prism added color, the red would split again. It does nothing. The color was already in the light. And if I recombine all the colors, red, green, blue, they make white light again. Light is not simple. It is a mixture. Newton proved that. But Newton's greatest question was not about light. It was about why things fall. Why the moon stays in the sky. Why the apple falls from the tree. Newton asked, does the same force that makes the apple fall also reach the moon? Could the moon be falling toward Earth, but moving sideways so fast it never lands? Here is the calculation. The moon is 60 times farther from Earth's center than the apple. If gravity weakens with distance, specifically the square of the distance, then the moon should fall at 3600th the speed of the apple. Newton calculated the moon's actual fall from its orbit. He compared it to the apple. They matched. The same force, gravity, holds the moon and drops the apple. The heavens and earth united. Newton gave us three laws of motion. An object in motion stays in motion. Force equals mass times acceleration. Every action has an equal opposite reaction. Simple equations. They built the modern world. But Newton had a secret. He wrote over 1 million words on alchemy, turning lead into gold, searching for hidden forces. He never published this. He was afraid of ridicule. Newton's laws were brilliant. They predicted almost everything, but not Mercury. Mercury's orbit shifts slightly every time it goes around the sun. Newton's laws predicted most of that shift, but there was a tiny leftover, 43 arcseconds per century. Tiny, but real, and Newton could not explain it. Astronomers searched for a hidden planet near Mercury. They looked for a dust cloud. They measured the sun's shape. Nothing worked. Newton's perfect clockwork universe had a catch. For 200 years, no one could solve Mercury. Newton's laws were wrong, but only by a hair. It would take another genius to see why. A patent clerk named Albert Einstein.